Hello students. Today we are going to discuss about the swapping, contiguous allocation and paging. In this platform, we are discuss about first of all we are going to discuss about the swapping. So basically, swapping is a method in which the process should be swapped temporarily from main memory to the backing store, right? So it will be later brought back into the memory from the continue execution, right? So swapping, play a very vital role because the backing store is a hard disk or some other secondary storage devices that should be big enough to in order to accommodate copies of all memories images for all users. It is also capable of offering direct access to these memory images, right? So see here, uh, in the operating system there is a user space. It means that there is a main memory is over there. There is a RAM, right? So swap in and swap out method is used over there. If supposed to be, we CPU wants to execute P1, then it be loaded on the main memory user space. And if supposed to be at the same time, RAM needs to execute, process P2, and then it be swept in. Okay, so this is the concept. If supposed to be process 1 are executed, then swap 2 is so process 2 is swept into the secondary memory. And if CPU required P2, then it can move and swap in the user space, where the number of job, or we can say that critical section, their particular job is can be executed over there. So this is the concept of swap in and swap out. So what is the benefit? If we are discuss about some certain kind of benefits related with swapping, so here there are major benefits of it offer higher degree of multiple programming, right? So basically, multi-programming means that multiple programs are executed at the same time. So it offers what it offers the high degree of multi-programming, as well as allows dynamic reallocation. It can permitted dynamic reallocations. For example, if address binding at execution time is being used, then process can be swapped in a different location. Else, in case of compile and load time bindings, process should be moved to same location, right? So it permitted, basically it can permit, it allows dynamic relocation. For example, if address binding at execution time it being used, then process can be swept, right? Swap in different locations, as well as it helps to get better utilization of memory. It help what it help to get what it gives us. It help us to get better utilization of memory, right? So if supposed to be we have a less memory, then we can with the help of swap in and swap out method, we can easily execute our program, right? So minimum wastage of CPU time on completions, so it can easily be applied to priority based, right? So scheduling method is improved, it is performance, right? So minimum wastage of CPU time on completions of it can be easily be applied to the priority basis, right? So if supposed to be we have already discussed that if we require to implement our process P1, right? So it can be loaded on the main memory, right? And with the help of main memory, it can be executed. But if supposed to be at the same time we have required P2, process 2, which we want to execute same on the main memory, then it is very easy to utilize over here, right? So this is all about the priority based scheduling method to improve the its performance, as well as, right? So swapping is a memory management scheme, basically. If we are going to discuss about the swapping, so swapping basically is a memory management scheme in which any process can be temporarily swapped from main memory to secondary memory, so that the main memory can be made available for other processes, right? So swapping is a memory management scheme, basically in which any process can be temporarily swapped, right, from main memory to secondary memory, so that the main memory can be made available for other processes. It is used to improve main memory utilization, as well as what it can help. It is used to improve what it can improve main memory utilization, as well as in secondary memory. The place where the swapped out process is stored is called swap space, right? in the secondary memory there is a certain kind of space, right? So particular this space we call swap space as well. As the purpose of swapping in operating system is to access the data present in hard disk and bring it to RAM so that application program can use it, right? So basic agenda of this particular swap in and swap out method is like purpose is that in the operating system and that we can access the data present in what in the hard disk and bring it to RAM, right? So basically, we already discussed about the main memory. So basically, main memory is nothing but this is the RAM, right? And it's supposed to be we have a certain kind of a program, and that program is consist of certain kind of process, different numbers of process which is used to execute. So it can take a data from hard disk as well as, right? So it is very easy to understand the things like the purpose of the swiping. So basically, the purpose of the swapping is nothing but it's all about that we can how we can use the hard disk, space with the help of RAM, right? So the thing to remember is that swapping is used only when data is not present in the RAM, right? So while it's supposed to be CPU wants to execute any kind of process and the particular process is not over there, it is present in the secondary memory, then we can use a certain kind of swapping concept, right? So the thing to remember that swiping is used only when data is not present in RAM. Although the process of swiping affects the performance of system, it helps to run larger and more than one process. This is the reason why swiping is also referred to as a memory compaction, right? So although we already discussed about the process of swiping affects the performance as well as of the system, it helps to run larger and more one process at a time, right? So this is the reason why swiping is also referred to as a memory compaction, right? So the concept of swiping has divided into two or more concepts, like swap in and swap out, right? So if we are going to discuss about the swiping, so swiping is nothing but is the exchange of a process from main memory to the secondary memory to the main memory. But this concept is divided into two another concepts, that is the swap in and swap out, right? So if we are going to discuss about the swap out, is a method of removing of a process from RAM and adding it into the hard disk, right? If suppose we use swap out method, then what thing we have done, we can swap out, means that process are working over there in the RAM, are present in the RAM, then if we can remove from RAM and adding it into the hard disk. This is the concept of swap out. But it's supposed to be at the same time we discuss about swap in is a method of removing a program from hard disk and putting it back into the main memory or RAM, right? So this is the basic concept of of swap in and swap out, right? So if suppose we are going to discuss about the example. Suppose the user process size is uh, 2048 KB and it is standard hard disk where swapping has a data transfer from 1 Mbps. Now we will calculate how long it will be take to transfer from main memory to the secondary memory. This is the best example to understand, right? So user process size is equal to 2048 KB, right? And data transfer rate is 1 Mbps, right? Is equal to 1 Mbps is equal to 1024 kbps, right? So time is equal to process size upon transfer rate. So process size is equal to 2048 and transfer rate is equal to 1 Mbps. So like 1 Mbps is equal to 1024 kbps, right? So this is 2 seconds. So within the 2 seconds it can be transferred. Okay, so we required 2000 milliseconds to cover it, right? So now taking swap in and swap out, time out, the process will take 4000 milliseconds as well as, right? So it's very simple thing that we can easily use. So advantage, if supposed to be we are going to discuss about the certain advantage of swapping. So it helps the CPU to manage multiple process within a single main memory, right? So it can help what it can help it help the CPU to manage multiple process within the single main memory as well as it helps to create and use virtual memory as well as swapping allows the CPU to perform multiple tasks simultaneously. Therefore, process do not have to wait very long before they are executed. It is improves the main memory utilization. So these are the certain advantage of the swapping. So if we are going to discuss about the disadvantage of the swapping, so if the computer system loses power, the user may lose all the information related to the program in case of substantial swapping activity. If the swapping algorithm is not good, the composite method can be increase the number of page fault and decrease the overall processing performance. Right. So page fault, page hit is very important parameters if we are using the swapping method concept. So if supposed to be CPU wants to ask the main memory tab for the process and process is not over there, so it means that it can page fault occurs, right? At the same time, if supposed to be there is a process is over there, if CPU wants to execute any kind of process and the process is present in the main memory, so we can say that page hit occurs over there. Okay, so if we are going to discuss about the swapping algorithm is not good, then what thing happen? Then composite method can increase the number of page fault and decrease the overall processing performance. If many times a page fault occurs over there, it means that the CPU wants to execute the process, but process is not available in the main memory. So what thing happened? Just in imagine what thing happened that again and again it can request to the process for the main memory from the main memory ask the process to the hard disk, right? So hard disk send swap in and swap out concept is over there. So increase the number of page fault occurs, then it can also decrease the overall performance of our system, right? So it's supposed to be there is a note over there in a single tasking operating system. Only one process occupies the user program area memory and stay in the memory until the process is completed. In multitasking, right? It's supposed to be we are going to discuss about the multitasking operating system. The situation arises when all the active process cannot be coordinated in the main memory, then the process is swipe out from the main memory so that other process can enter it, right? So this is all about the swiping concept. Now we are discuss about the contiguous allocation. So if the block are allocated to file in such a way that all the logical blocks of the file get the contiguous physical block in the hard disk, then such allocation scheme is known as contiguous allocation, right? So basically, what it means that if the block are allocated to a file in such a way that all the logical of blocks of the file get the contiguous physical block in the hard disk, then such allocation is all about the contiguous allocation. In the image showing below, there are the three files in the directory. The starting block and the length of the each file are mentioned in the table. We can check the table that the contiguous blocks are assigned to the each file as per the it is need, right? So here you see that here there is a hard disk and there is a directory, and it's supposed to be we have a certain kind of block file name abc.txt start from 0 and length is equal to 3, then allocated blocks 0 1 2 0 1 and 2, right? So it's supposed to be we have a video.mp file name, then start from 4 and there is a length is 2 and there is a 4 and 5 block is used, right? So like jtp docs file is there and there is a starting point is 9 and there is a length is 3, right? So here only 9 10 and 11 directory allocated blocks is over there. In case of 2 where there is a video, we can start from 4 and 5 only blocks 4 and 5 is used in the hard disk. So this is the best example of contiguous allocation. So if we are going to discuss about the advantages of contiguous allocation, so it is simple to implement. Basically, it is very simple to implement. We can allocate with the help of certain blocks. We can execute or we can allocate simple terms. It is simple to implement. We will get excellent read performance as well as we will what we will get we will excellent read performance as well as supports random access into files. And it's supposed to be we discuss about the disadvantage of the particular same, then the disk will become fragmented, right? There is a certain kind of fragmentations which we have already discussed, internal fragmentation and external fragmentation. Here there is a certain disadvantage, become the fragmented. It may be difficult to have a file grow as well as, right? So these are the in but it's supposed to be we go with a detailed description of contiguous memory allocation. So each process is contained in a single contiguous section of memory. In this memory allocation, all the available memory space remains together in one place, right? Which implies that freely available memory partitions are not spread over a hair and there across the whole memory space, right? And so we can divide it contiguous memory management technique with fixed size partition scheme and variable size partition scheme. We will cover the concept of different contiguous memory allocation like fixed size partition scheme. So in this technique is also known as static partitioning, right? So in this scheme, the system divided the memory into the fixed size partition. Here in the static, we discuss about the system divides the memory into fixed size, right? Partition. The partition may be or may not be the same size, right? The size of each partition is fixed as indicated by the name of the technique, and it is not to be changed, right? So in this partition scheme, each partition may contain exactly one process. There is a problem that this technique will limit the degree of multi-programming because the number of partitions will basically decide the number of processes. Whenever any process terminates, then the partition becomes available for another process. Let us take an example of fixed size partitioning scheme. We will divide the memory size of 15 KB into fixed size partition, right? So we have distributed 15 KB with 5 KB, 2 KB, 3 KB, 3 KB, and 2 KB, like that. It is important to note that these partitions are allocated to the process as they are arrived, and partition that is allocated to be arrived process basically depends on the algorithm followed. If there is some wastage inside the partition, then it is termed as a internal fragmentation, right? And so this is the basic concept of the paging allocations, contiguous allocations, right? So another our topic is all about the paging. So paging is also is a storage mechanism that allows operating system to retrieve process from secondary storage into the main memory in the form of pages. In the paging method, the main memory is divided into small fixed size block, right? So basically, it can divide it into the fixed size block into main memory in the form of pages. In the paging method, the main memory is divided into small fixed size block of physical memory, which is called frames. The size of frames should be kept the same as that part of page having maximum utilization of main memory, and to avoid external fragmentation, paging is used for faster access to data, and it is logical concept. So in this paging tutorial, you will learn a lot of things like what is the paging protection, advantage, disadvantage, segmentation, advantage of segmentation, and disadvantage of the segmentation. With the help of this example, for we can easily learn that if the main memory size is 16 KB and frame size is 1 KB, right? Here then main memory will be divided into collection of 16 frames of each 1 KB, right? So there are four separate processes in a system, that is A1, A2, A3, and A4 of 4 KB each. Here all the processes are divided into pages of 1 KB each so that operating system can store one page in one frame, right? So at the beginning of this process, all the frames remains empty so that all the pages of the process will be get stored in the contiguous tree, like that, right? So if process A1 required to insert, then it can easily be inserted over there. If process P2 A2 is required to insert all the process, then it can be there is a certain kind of process partition is over there. Each and every kbps is divided into the frame. So each and every frame, one frame is equal to 1 kbps, so frame size is equal to page size. So we can easily distribute it over there with the help of main memory, right? So like A3 we can distribute it 4 kb, and we can use with 4 frames as well as, like vice versa of A4 size, right? So in this example, you can see that A2 and A4 are moved to waiting state after some time. Therefore, 8 frames becomes empty, and so other pages can be loaded in that empty blocks. The process A5 of size 8 pages, 8 KB are waiting in the ready queue, right? So in this regard, we discuss about that A5 is over there for with the 8 KB, so it can wait to execute, right? So it's supposed to be there is a in this before that we have discussed about the A2, right? So it's supposed to be there is a A2 is completed, then it can be replaced with the A5, right? And A5 is replaced with another A4 as well as, right? So this is all about the paging concept. So in this example, you can see that there are 8 non-contiguous frames which is available in the memory, and paging offer the flexibility of storing the process at different places. This allows us to load the pages of process A5 instead of A2 and A4, right? So what is the paging protection? So it's supposed to be, we are going to discuss about the paging protection. So paging process should be is protected by using concept of insertion of an additional bit called valid or invalid bit. Paging process, paging memory protection in the paging is achieved by associating protection bits which with each page. These bits are associated with each page table entry and specific protection on the corresponding page. Advantages of paging. Here there is a certain advantage of using paging method: easy to use memory management algorithm, no need of external fragmentation, and swapping is easily between the equal size pages and the frame. Disadvantage of the paging, here there is a drawback over there, so may cause internal fragmentation, right? So complex memory management algorithm, page table consume additional memory, multi-level paging may be lead to the memory reference overhead, right? So these are all about the topics, and there is a certain MCQs. So here we are going to discuss about what is the address binding, right? Going to an address in the memory, allocation, locating an address with the help of another address, binding two addresses together to form a new address in the different memory space, a mapping from one address space to another. D is the right answer, the mapping from one address space to another space. Binding of instruction and data to memory address can be done at compile time, load, execution, all of the above. D is the right answer. So binding of instruction and data to memory address can be done at compile time, load time, and execution time. If the process can be moved during its execution from one memory segment to another, then binding must be delayed until runtime, prepared to compile time, prepared preponed to load time, none of the above. So A is the right answer, that is the delayed until runtime, right? So what is the dynamic loading? If we are going to discuss about the dynamic loading, so the loading multiple routines dynamically, loading a routine only in the called. So B is the right answer, that is the loading routine only when it is called, right? So what is the advantage of dynamic loading? So B is the right answer. An unused routine is never loaded. Idea of overlays is to dash. D is the right answer, that data that are need to be in a given time is also right answer. Enable to a process to larger than the amount of the memory allocation is to keep in the memory only in this instructions. The dash is must design and programs the overlay structure. So A is the right answer, programmer. The programmer must design a program, the overlay structure, right? So dash is swipe process in and out of the memory manager, cpu manager, user. So A is the right answer, memory manager. The memory manager swipe swipes process in and out in the memory. Higher priority process arise and wants service, the memory manager can swipe out the lower priority process to execute the higher priority process. When the higher priority process finish, the lower priority process is swiped back in the contiguous allocation execution. This variant of swiping is sometimes called C. There is a roll out and roll in, roll out and roll in. Binding is done at assembly or load time, then the process dash can be moved to different location after being swapped out in the again. So C is the right answer, that is can never. Right? In a system that does not support swapping, so A is the right answer. The compile normally binds symbolic address variable to reallocate the address, right? So these are the certain things that we have discussed about the swapping, about the contiguous allocation, and different kind of paging. So if we can revise our today's topic, so we are already discussed about the swapping. Swapping is a method in which the process should be swapped temporarily from the main memory to a backing store, right? It will be later brought back into the memory for continue execution as well as. Okay, so basically, memory management is the functionality of an operating system which handle or manage primary memory sorry, and moves processes back and forth between the main memory and disk during the execution, right? So memory management, we basically keep track of each and every memory location, regardless of either it is allocated to some process or free, right? So it checks how much memory is to be allocated to the process. Decide which process will be get memory at what time. So it tracks when some memory gets freed or unallocated, and correspondingly it updated the status. So basically, process address, also very important component as well as on the perspective. But if we discuss about the swapping, so swapping is a mechanism in which a process basically okay. So swapping is a mechanism in which a process can be swapped temporarily out of main memory or moved to secondary storage disk and make it memory available to other processes at the same time, right? So uh, at the some later time, the system swept back to the process from secondary storage to the main memory. Through performance, it is affected by swapping process, but it will help in the running multiple and big processes in the parallel, and that reasons swapping is also known as technique of for memory compaction basically, right? So memory compaction, we called swapping, we called as memory compaction. So there is a certain main memory and different kind of process P1, P2, and number of processes over there, and there is a secondary memory. There is a process P3, P4, and Pn number of processes there. So in case of swap in and swap out, so if supposed to be swap out means that process move from main memory to the secondary memory, and swap in we say that process move from secondary memory to the main memory for the execution. The total time taken by swap process, including the time it takes to move entire process secondary disk and then copy process back to the memory, as well as the time process as well as, right? So this is okay. So this is all about the example of swap in and swap out, memory allocation. So basically, we discuss about the memory allocation. That is low memory, the operating system reside in this memory, and high memory, the user processes are held in the high memory. So memory allocation description, single partition allocation also very important. Multiple partition is allocation is also very important for the same. that is the part of this, uh, right? So swapping basically is a method in which the process should be swept temporarily, right? So we can, okay. Here there is a swapping concept. In this figure, we have already discussed that what is the swap in and swap out concept. So it's supposed to be the process move from the main memory to the secondary memory, then we can call it swap out. And it's supposed to be the process move from the secondary storage to the main memory, then we can say that it is swap in. Benefits, there are a lot of benefits is over there for the swapping. If we are considering this kind of thing of basically on the basis of memory allocation as well as, so it offers the higher degree of multi-programming, right? So we, with the help of swapping concept, we can also improve our multi-programming in the operating system. So allows dynamic reallocations. For example, if we address binding at execution time is being used, then process can be swept in a different location. Else, in case of compile and load time binding, the process should be moved to some location. It helps to get better utilization of memory, minimum wastage of CPU time on completion, so it can easily be applied for priority based scheduling method to improve its performance. Swapping basically is a memory management, right? So with the help of swapping, we can easily say that we can execute our very big program with the multi-programming, right? So swapping is a memory management scheme in which any process can be temporarily swapped from main memory to secondary memory, so that the main memory can be made available for other processes. It is used to improve main memory utilization as well as secondary memory. Place where the swapped out process is stored as is called swap back space, right? The purpose of swapping in the operating system is to access the data present in the hard disk and bring it to RAM, so that application program can use it, right? So it is very much easy. Okay, so it is used to improve main memory utilization. In secondary memory, the place where the swapped out process is stored is called swap space. The purpose of swapping in operating system is to access the data present in the hard disk and bring it to the RAM. The thing to remember is that swapping is used only when data is not present in the RAM. Basically, while we are going to discuss about the swapping, so we are aware about that CPU wants to execute certain kind of process, and basically the process is available in the RAM memory, right? So at the same time, if supposed to be process wants to execute any kind of process, but process is not available in the RAM, so it can page fault can occur. So this is the thing that we can say that we can, it can help or improve to the swapping concept. So although the process of swapping affected the performance of system, it helped to run larger and more than one process, right? So basically, if we are going to discuss about the thing to remember here, that is, basically, although the process of swiping affects the performance of the system, it helps to run larger and more than one process. This is reason why swiping is also referred to as memory compaction as well as. The concept of swapping is divided into two main concepts, two more concepts, that is swap in and swap out. So with the help of swap out is a method of removing the process from RAM and adding it into the hard disk, right? So very easy concept over there with the swap out. So method of removing from a process from RAM, from the main memory, and adding it to into the hard disk, right? So if supposed to be, we, why we remove, because we required some space to execute any other process. So that's why what should we do, we can swap out from process from the main memory, because there is a main memory is limited memory, okay. And swap in. So in swap in, the method of removing from a program from a hard disk and putting it back into the main memory or RAM, right? So it's supposed to be CPU call any kind of process which CPU wants to execute, but it is not available in the main memory. So what thing happened? So we have required swap in method. So with the help of swap in method, we can swap the process from hard disk to the main memory as well as, right? So this is the best example that we have already done, that how data can be transferred from one to another with certain things. So advantage of swapping, and a little bit we have going to discuss about certain advantage, because we have already discussed certain advantage of swapping, is that basically it can use for improving our performance of the system, because if supposed to be we have a large or huge program and we want to execute, and we have a limited kind of main memory over there, so we can use certain kind of swapping concept to swap in and swap out. With the swap in and swap out method, we can we have used multi programming as well as. So it help to create and use virtual memory as well as, right? So with the help of certain things that we have done over there. Okay, so swapping allows the CPU to perform multiple tasks simultaneously, right? So multiple tasks means that we have a open a lot of application together, and we can wants to execute with the same time. So simultaneously it can work. So it's supposed to be you have a use multiple jobs at the same time. So we have required swapping, because at the same time our RAM is too small to execute all the program at simultaneously. Then what thing is required? Then we have used swap in and swap out method over there. So therefore the process do not have to wait very long before they are executed, and improve the main memory utilization as well as. So these are the certain advantage. So a little bit there is a certain disadvantages over there. So if the computer system loses power, the user may lose all information related to the program in case of substantial swapping activity. So if supposed to be there is a you are using a system which is connected with power. So at the same time, if power is going to be locked, then what thing happen? Then we have lost all the activities which we have done over there, swapping, with the concept of swapping. So maybe there is some program are not executed properly, some certain there is a certain kind of problems create occur over there. So if the swapping algorithm is not good, the composite method can increase the number of page fault and decrease the overall processing performance. So it's supposed to be at the same time we are going to discuss about the disadvantage. Then if we are using certain kind of algorithm which is not too enough good for the multi-programming as well as. So what thing happen then? It can create multiple page fault occurs, because what time the page fault is occurs, then CPU wants to execute any kind of process, and it can request to the main memory, but in the main memory there is a no processors available, so main memory requested to the secondary memory as well as. And then after that secondary memory can send with the help of swap in method, using of swap in method, then at that time we called it page fault occur over there. So it's supposed to be multiple times the page fault is occurs over there, then what thing happen? Then the performance of basically the processing performance is going to be very slow. So this is also basically the disadvantage of the swapping. There is certain note which is very important to understand the things, right? So here there is a certain contiguous allocation. Memory allocation and contiguous allocation is the same thing. So if the blocks are allocated to the file in such a way that all the logical blocks of the file get the contiguous physical block in the hard disk, then this such allocation is basically we have discussed such kind of things like file get contiguous physical blocks and all. Right? So in the image showing below, if there are three files, the directory, the starting blocks, and the length of the each file is mentioned over there. So here we see that there is a file, there is a abc.txt. So it is starting from point is 0 and length is equal to 3. So it required three blocks, right? So from 0, 1 and 2, 3 blocks can be executed over there, right? So with the help of this example. So there is another file, that is the video.mp4 file is over there, and the starting point is from 4, and length required is 2 block, right? So only 4 and 5 blocks is used over there. Like JTB.docs file is over there, starting from 9, and there is a length is 3. So it means that only 9, 10, and 11 is used over there. This is the contiguous allocation, right? So at the same time, the starting point is there, so we can easily find out the length, and it's supposed to be there is a 4, 3, 4, 5. Then we can easily with continuation form, we can easily find out. So advantage, so it is very simple to implement. If we are going to implement, then it is very simple to implement. We will get excellent read performance as well as support random access into file. Disadvantages, disk will be becomes fragmented. It may be difficult to have a file grow, and if supposed to be, we can discuss about the contiguous memory allocation. Each process is contained in single contiguous section of the memory. In this memory allocation, all the available memory space remains together in one place, which implies that the freely available memory partition are not spread over there and there across the whole memory space. In contiguous memory allocation, which is the memory management technique, whenever there is a request by the user process for memory, then single section is over there. There is a fixed size partition, and if supposed to be we are discuss about the memory can be divided either in the fixed size partition or variable size partition in order to allocate the contiguous space to the user process. So we can divide it into the two parts. One is the fixed size partition and the variable size partition. So this is all about the contiguous and non-contiguous memory allocation as well as, right. So we have already discussed that this technique is also known as static partitioning. In this scheme, the system divided in the memory into fixed size, right. So this is all about the static partition. So we can divide it. Supposed to be here in this example that if suppose we have a process and it only required the 2 KB space, then it can be implemented where we can allocate in the 2 KB space where we have allocated over there. So it is important to note that these partitions are allocated to the process at the arrive, and partitions that is allocated to the arrive process basically. So it can also if there is some wastage inside the partition, then it comes as a internal, right. So paging also very important topic, and with the help of paging we can say that it is a storage mechanism that allows operating system, right. So it can permit the operating system to retrieve for a process from the secondary storage into the main memory and the form of pages. In the paging method, the main memory is divided into the small fixed size blocks, physical memory which is called frames, size and all, right. So in this example, you see that we have a 16 KB main memory collection of the frames and paging. So we can distribute one frame is equal to 1 KB size. So frame size, basically we can distribute a frame size equal to page size. So if supposed to be we have a page is all about the uh, uh, you know 16 KB, then we can distribute it main memory into the 16 KB with 16 frames, like we can distribute it, right. So it can easily be executed if one by one we can process A1, A2, A3, A4 like that. So in detail we have already done, and supposed to be at the same time we want to execute it another memory, then we can easily implement it. So basically here the question arise that what is the protection, what is the paging protection. So paging process should be protected by using concept of insertion of an additional bit like valid non invalid bit out there. Advantage, it's supposed to be we are going to discuss about the certain advantage, then there here are the some using certain advantage over there with the advantages, easy to use memory management algorithm. So little bit there is a certain disadvantage. may cause internal fragmentation, complex memory management, and page table consume additional memory, multi-level paging, and may lead more and more reference overhead. So this is all about the certain different topics that we have covered. Thank you very much.